Welcome all of you to this video of Maths Made Easy Academy. Now in this video I am going to take up sums from work, power and energy. So all the sums that are there from work, power, energy that can be important, I am trying to do here for you. Okay, so listen carefully because there is going to be a wide variety of sums from the entire chapter. Okay, let's start. Here a boy of weight 40 kg climbs 15 steps each. Okay, and each step is of 15 centimeter. This is a very important one. First, this is the weight of the boy. Number of steps is here 15 steps. Each of 15 centimeter. Note the mismatch. This is not SI. This is SI. Okay. And here he does it in 10 seconds. And of girl of weight 20, again weight of the girl given, and does the same work. That means she also goes for 15 steps, 15 seconds. Okay, in 15 seconds, this time girl takes less time, 5 seconds. Girl's weight was also less. Compare their work done and the power of both the girl and the boy. Comparing means you have to find the ratio. Okay, so let's start. Firstly, the boy 40 kg weight. So what is the work done by the boy? Okay, work done by the boy, that is how much work done by the boy, that is, work is always force into displacement, right? So force into displacement. What is the force? If he is weighing 40 kg, that means he has to lift his weight up by 40 kg, means the earth is pulling him by 40 kg and he has to go against it and pull his body by 40 kg, only then he can climb the stairs. So 40 kg is the force. Okay, 40 kgf is the force, but we can't use kgf in a sum. We'll have to use this 10 and turn it to Newton. So here now it becomes Newton into how much distance does he go up. This time the movement is vertical, it is not horizontal, but then there is a movement. So the boy is pulling himself up like this, displacement force is acting like this, and also displacement is also happening in the same line along with the force. So no problem, we can multiply force with displacement because force and displacement are working in the same direction. So now displacement is how much? 15 centimeters. Okay, so 15 centimeters is the displacement by, no, centimeters we have to convert to meters, convert it here only, don't use extra steps. 15 centimeters, and there are 15 of such steps. Okay, so this is my displacement. Now that comes to 900. 900 what? 900. Now if this is work, it is joules. Now work done by the power of the boy. Okay, very simply, power is always work by time. So time is how much? He does it in 10 seconds. So by 10. Okay, 90 watts. So if this is in joules, this is in seconds, work is in joules, time is in seconds, you get your power in watts. Now let's see what the girl does. Okay, so girl is 20 kgf, does it in 5 seconds. Okay, so quickly we'll get the work for the girl also. So work done by the girl. Okay, work done by the girl. Work done by the girl is equal to, again, force. Now we convert it to Newton. Okay, into, now there are 15 steps. Yes, 15 steps, each 15 centimeter. Same thing. So here, so this is 2 into 225. That is 450. That is 450 joules. That's the work. Power is 450 by, she does it in 5, again 90 watts. Okay, so ratio of power comes to 1:1. You can do it and show. Ratio of work. Ratio of work. Now if I take this as WB and if I take this as WG, then WB by WG, work by boy, work by girl, that comes to 900 by 450, which is 2 by 1. Okay, therefore ratio is equal to 2:1. Okay, so that was this sum. We'll quickly do the next sum. So this was one sum. This is very often asked. Here, power of a motor is 40 kilowatts. At what speed the motor raises a load of 20,000 Newton? Okay, so power of a motor is given at what speed? Now why did I take up this question? I took up this question because there is a formula many of you miss. Power is equal to force into velocity. It can actually be proved, but we are using the ready formula. Remember this, power is force into velocity. Okay, now power we will write here. Remember it is in kilowatts. At what speed and a load of this means this becomes the force. 20,000. Okay, 20,000. Now if it is in kilowatts, let me make it in, this is watts now. Okay, and then V. So at what speed? Direct question. Okay, don't keep thinking what do I use. You have to use this formula which is given in concise physics. So here 1 2 3 4 1 2 3 4 V is equal to 2 meters per second. Everything is in SI. What is in SI? This force is in Newton, so you are going to get it automatically in meters per second. Now we have a question here. An electric heater of power 3 kilowatts used for 10 hours. We have to keep noting the units. Okay, kilowatts and hours. It is given in kilowatt and hours. How much energy does it consume? Express in kilowatt hour and joule. Okay, so you have to express the answer energy in kilowatt hour and also in joule, in both ways. Firstly, I'll do the kilowatt hour part of it. Now since power is given in kilowatts, let me write it straight. I'm not changing it to watts because I'm not changing this kilowatt to watt because here also I have hours, so I'll put time hours. I'll not change this to seconds and not change this to watts. Why? Because finally I want my answer in kilowatt hour, so I'll keep them in kilowatt and hour. Okay, and then here energy. Now energy is equal to 30 kWh. As simple as that. This can be asked in an MCQ, so don't do big processes for it. Here let me find it in joules. Then energy, this is in kilowatt hour. Let's convert it to joules. This is simply into 30 into 3.6 into 10 to the power 6. Okay, that makes it 10.8 into 10 to the power 6. 10.8 into 10 to the power 7. Okay, then it is, but then if we have to write it in the standard form. These answers, when you have such big numbers in 10 to the power something, get it in standard form always, and that is, if I have divided it by 10 here, 1.08. okay, then I will have to multiply it with 10. So this is the standard form of writing this many joules. So I got my answer straight away in kilowatt hour and then I got it in joules. Okay, so this sum is done. Let's do the other sum. Water pump 50 liter of water through a height of 25 meters in 5 seconds. Water pump 50 liters of water through a height of 25 meters in 5 seconds. Calculate the power. We have to get the power of the pump required, and G is given, density of water is given. Water pump raises 50 liter of water. Now we don't have anything to do with volume of water, but then why have they given? Okay, because we don't know how much weight the water pump is picking up. So, and through a height, this is naturally the displacement. Here is the time. This 50 liters, let's see what we can do. Okay, now what volume of water? First thing, volume, which is 50 liters. Let me convert it to centimeter cube. Okay, I converted it to centimeter cube because 1000 cc centimeter cube is equal to 1 liter. So this is in cc, but I don't want my answer in cc now. Why I do this in cc is because I remember only one change in unit, that is this. From that I convert always. Okay, now here it is 50 liters and here it is meters, seconds. I can see all SIs here after this. So it is better to convert this to meter cube. So if this is cc, now how many? I need 300s to convert it to meter cube. If it is meter square, I'll need 200s. Okay, so 1, 2, 1, 2, 3, 4, 3, 4, done. This is 1 by, volume becomes 1 by 20. 1 by 20 meter cube. Now we are going to work with this volume. But then again, volume also does not work. Then again, volume also is not enough. We need to know how much is the weight of the water that was lifted up. So now how to find weight? Now remember, density is equal to mass per unit volume. Remember this formula? Okay. So now what I am going to do? I am going to put density here, volume here. In that case, mass is equal to, density is given 1000 for water and it is in SI, and volume is 1 by 20. So this becomes, so here we get a 50 kg, but then this is still mass. It is still mass. We have to convert it to weight now. So 50 with this 10, okay, that is because weight is always equal to mass into m into g. I got m, I am converting it to g into the 10, 500 Newton. Finally, I got the weight of water. Now this is being picked up by through a height of 25 in a time of 5 seconds. We need the power of the pump required. How much is the work done? Work done in lifting it, 500 into, that is 25. Okay, I'll just leave it like that. This is in joules. Okay, power is 500 into 25 divided by 5, right? Divided by 5, and then this comes to 2500 watts. Energy by time. So this was one sum where the problem was here. Problem was here. The problem was not here. So if you can do this correct kind of conversions from volume, how do you convert it to mass and then to weight? That is what is important here. So this formula, know it well. Energy formula, know it well. So how many formula did we use in here? First we used density formula, we used power formula, we used here work formula. 3 formula, and along with changing from centimeter cube to meter cube also we did. Okay, so remember all these things and you will definitely be able to do the sum. This should not come in an MCQ, this should come in the regular sums, okay, in the exercise, in the, either in part B or in part A. Okay, so now what I'm going to take up is the next part, that is I'm going to take up the sums from the kinetic energy part of it. Okay, so watch this properly. The most important questions, 3 questions will be taken from the kinetic energy part of it. So watch it carefully, very, very important sum. Now here there's a bullet of mass 50 grams, keep watching the unit. SI, it's not SI, it is CGS, moving with a velocity 500 meters per second, okay, it penetrates 10 centimeters to a still target and comes to rest. Calculate the kinetic energy of the bullet. So here, bullet has mass 50, velocity is 500, penetrates. Now supposing it is a wooden block, okay, and this bullet goes 10 centimeter into it and then stops. That is the story. Okay, then they are asking what is the kinetic energy of the bullet, and then they are asking how much is retardation. How much of retardation this block is giving? Of course, this block is giving some retardation. That is why the bullet is stopping. So first, kinetic energy. Okay, kinetic energy of the bullet, that is half mv square. Now they have given us this m, which is they have given in 50, and they have given this in SI. So half into 50 by 1000, isn't it? 1000, because we are converting it to kg, into 500 into 500. Okay, I'll not multiply 500 with 500. 500 into 500, and let me see how much I can cancel. Okay, here 25, then one more 0 goes, So it is 6250 joules, since it is kinetic energy. Okay. Now they didn't say how much of retardation, they said what retarding force, means what amount of force the target is giving to it. Now how much of work is done by the bullet, the same amount of work is done by the target, only then it can stop it. So F into D, it has gone inside by 10 centimeter, convert it to meter. Okay, force we have to find. Work is, what work is it doing? Now work that it is equal to the kinetic energy the bullet was possessing at that time. So when the bullet hits the target, at that time it has 6250 joules kinetic energy. This 6250 joules kinetic energy is being countered by the target and finally brought to a stop. So the work done by the target is also this many joules. Okay, so here we'll write 6250, remember. Okay, and then this force is 62500 Newton straight away. Okay, this question is one of the most important questions for teachers, for boards, everywhere. Okay, maybe they'll just change it from a bullet to something else, but then the concept will remain the same. Okay, same kind of questions are also asked for a car is moving, how much of time will it take for the car to come to a stop, or what force the brakes are applying and all that. So same type of question can be changed little bit and asked. Let's see the next important question. Okay, here truck weighing, weight of the truck is given in kgf, gravitational unit of force. Okay, changes its speed from 36 to 72, time taken for this change is 2 minutes. Calculate the work done and the power, means the truck was here, it moves here, here it was at 36, here it is at 72, and this is done in 2 minutes. 2 minutes. Okay, how much is the work done from here to here and how much is the power? Okay, very simply, there's a work energy theorem which says work is equal to kinetic energy here minus kinetic energy here. Okay, very simply, kinetic energy here minus kinetic energy here. So half m, but then before that we have to convert this to meters per second from kilometers per hour. 72 into 5 by 80, that is 20 meters per second, and 36 into 5 by 18 is 10 meters per second. Okay, now we'll work with those values because kph is not SI. Meters per second is SI. Half m v square, let me take this v here, this is small v, minus half m small v square. Okay, half m, now here it is how much? 400, straight away v square minus 100, right? And half m is how much? M is, see, if it is this much kgf, then the mass is only this part, only the number part is the mass from kgf into 300. That makes it 15. So it is 1.5 into 10 to the power 5 watt. We are finding work, so it is joules. Okay, so this is a very important question. This is a very important question on the work energy theorem. What you have to remember here is this. Okay, that is why I picked up this question. Okay, now how much is the power? Now that is very simple. How much is the power? We can easily find. Power is equal to work by time. So work is 1.5 into 10 to the power 5, and the time is 2 minutes. Okay, but then we need to convert this to seconds. So 2 minutes converted to seconds. Okay, here this is, if I again make it 150, if I make it 150, that means I have used up 2 of the zeros from here by 2 into 60. Let me see if it works. So this is how much? So 5, 3 5s are 3, 2s are. So this is, so it is 5 by 4, which comes to 1.25 into 10 to the power 3 watts. Okay, Two bodies of equal masses moving with uniform velocities v and 2v, find the ratio of the kinetic energies. Very simply, kinetic energy, okay, of the first one and kinetic energy of the second one. Now here mass is same, so half m and then v square, half m 2v square. This is where people go wrong. They write 2v square. So this 2 does not get squared. Okay, so now ratio is kinetic energy 1 by kinetic energy 2. That is very simple, half m v square by half m 4v square. Cut out, everything is equal. So it is 1:4. That is our answer. So these are few of the most important questions. Don't go to the examination without knowing these sums. I am again telling you, not that other sums can't come, but these are the tough ones and these are the most important. Okay, of course you should do other sums also in your concise physics. Okay, then keep watching the videos. Lots of other videos are going to be uploaded after this electromagnetic induction chapter, or magnetic effects of electric current, going to be uploaded with all DC motor and all that. So if you have not subscribed the channel, subscribe by now, because I'm going to, after this I'm going to upload videos in chemistry. Okay, very soon. Keep watching the playlist for new videos. Thanks all of you. Bye then.